NASA just announced that they are monitoring a huge escalating anomaly on the moon. Welcome to Space Destiny, friends, where we explore the mysteries of the cosmos. Join us on an exhilarating journey through the wonders of space, uncovering lunar secrets, deciphering celestial phenomena, and delving into the awe-inspiring depths of our universe. Over the past 50 years, numerous robotic spacecraft have explored the solar system, including the moon. Our moon has two distinct sides, the far side and the near side, which have puzzled researchers for a long time. Recently, astrophysicists at NASA uncovered the answer to this mystery. NASA is also observing a large and rapidly growing anomaly on the moon, sparking curiosity about potential threats to Earth. Guys, as NASA plans to send humans back to the moon by 2024, there still remains many mysteries that scientists hope to investigate. The moon has held a special place in human history, inspiring various mythologies and stories across cultures. Luna 3, the Soviet probe, first captured images of the moon's far side, leading to deeper understandings of its features. During the Apollo 11 mission, astronauts Buzz Aldrin and Neil Armstrong experienced a peculiar phenomenon as their lunar module landed on the moon. Moon dust covering the surface created challenges, but their mission was a success, and they made history. Today, we know that the moon's surface is covered by a veneer of dust, not a swallowing danger as once feared. The Apollo 11 mission was not primarily focused on lunar research, but the 6 subsequent crewed missions and various robotic missions significantly advanced our knowledge of the moon. The Apollo astronauts brought back over 2,000 moon rocks, enabling scientists to estimate the moon's age, composition, and formation. Despite these significant achievements, some fundamental questions remained unresolved for decades. In 1993, Japan's Hidden Lunar Probe intentionally deorbited, and there was a gap in lunar exploration until late 2000, when missions by NASA, China, India, and Japan heralded the beginning of the second era of lunar exploration. Over the past decade, 14 missions from 4 space organizations have successfully landed spacecraft on or near the moon, including China's recent historic rover mission to the far side. For planetary scientists studying the moon, this increased interest in lunar exploration is exciting as they seek answers to pressing questions. One puzzling issue is that the moon rocks brought back by the Apollo astronauts date to around 3.9 billion years ago. But there was hardly any rock from the moon's first 600 million years of existence, despite the moon being only about 60 million years younger than the solar system itself. The explanation proposed for this is the late heavy bombardment, or lunar apocalypse, suggesting that around 3.9 billion years ago, the moon experienced frequent impacts. One theory attributes this bombardment to large pebbles sent toward the moon as outer planets migrated outward. However, another opposing theory suggests that sampling bias might be responsible for the overabundance of 3.9 billion-year-old rocks. Friends, to solve the lunar cataclysm controversy, scientists aim to gather new samples from less tainted regions, such as the moon's far side or south pole. If the majority of these new samples prove to be older than 3.9 billion years old, it could challenge the lunar cataclysm theory and provide a better understanding of lunar history. The origin of lunar water in the early solar system remains a question of interest for scientists. Apollo 15's discovery of water inside a rock sample nearly 40 years after leaving the moon opened up new research possibilities. Data from India's Chandrayaan-1 mission confirmed the presence of water ice near the lunar poles, making it valuable for future lunar missions for purposes like rocket fuel and life support. There are 3 main hypotheses for how lunar water might have appeared. One suggests water ice was deposited by encounters with asteroids and comets, which melted and made its way to the poles. Another theory involves ionized hydrogen from solar winds interacting with oxygen in the regolith, escaping as vaporized water. The third hypothesis proposes water existed in the moon's initial material and was brought to the surface by volcanic eruptions. However, further research is needed to determine which process contributed how much water to the moon. The Lunar Crater Observation and Sensing Satellite, or LCROSS, found water and other comet-like components on the moon's surface, indicating water might have arrived through asteroids and comets. To better understand the source of lunar water, it's crucial to send a robot or person to collect samples and analyze their isotopic makeup. The concentration of lunar water in the poles is still a topic of debate. Even if the origin of the water is identified, questions about its migration to the moon's surface after comets and asteroid impacts remain unsolved. The moon's craters serve as a history book of the early solar system due to its stable surface and lack of significant atmospheric and volcanic activity. If surface samples support the existence of a lunar cataclysm, it could provide valuable insights into the formation of the solar system. A lunar cataclysm would imply that not only the moon, but also Earth and the other planets were once much closer to the sun. Any water on Earth's surface would have been destroyed, eradicating any potential life. Studying the moon's early history can also shed light on the early rotation of the sun and how it affected other planets like Venus and Mars. Recent research by Saxena and colleagues suggests that the sun's rotation was likely 50% slower during the first billion years of its existence. Based on the chemistry of the lunar crust, the moon contains fewer salt and potassium compared to Earth, and studying this difference helps understand the solar activity and rotation speed of similar newborn stars. As NASA and other space organizations plan for a sustained human presence on the moon, there are still critical questions to address. The moon serves as a stepping stone to understanding other planets in our solar system. However, a new mystery has emerged concerning something massive beneath the moon's south pole. Behind the south pole, Atkin Basin, the largest impact crater in the solar system. Speculation suggests it could be a piece of heavy metal from a past impact, but its exact nature remains uncertain. For now, guys, scientists know that this massive blob alters the moon's gravitational pull, but it's unclear why it remains immobile despite the moon's interior activity. The blob's immense size is estimated to weigh around 2.4 quadrillion US tons, but its origins and properties still pose intriguing questions. Imagine burying a mass of metal 5 times the size of Hawaii's Big Island underground. Such an unexpected discovery is helping us to understand why the two sides of the moon are so dissimilar. When you look at the moon from Earth at 9:30 p.m. after dinner, you see a bright orb with hazy, smooth black patterns. However, this is only one side of the moon we can see. The far side, which we cannot see from Earth, looks entirely different, lacking the distinctive gray patterns and featuring rough terrain with numerous craters. A recent study may provide an answer to this lunar dualism. It involves shadows, a significant impact that occurred billions of years ago, and lunar activity. Lunar Mar, the wavy hues seen on the moon's visible side, are composed of ancient lava from surface volcanoes. However, the far side lacks these features, even though one would expect both sides to have volcanic history. Scientists use computer simulations to recreate the massive impact that formed the South Pole Aitken Spa Basin, a giant crater on the moon's surface. This impact produced a plume of heat that transported certain chemical components to the near side of the moon, leading to lava flows visible on its surface. The far side was likely spared from this volcanic activity. Understanding these differences is helping scientists unravel the mysteries of the moon's formation and history, shedding light on its complex geology and evolution over billions of years. Interestingly, friends, the theory explaining the moon's dissimilarities also align with another puzzling feature. The near side of the moon contains substances like potassium, phosphorus, thorium, and other rare earth elements, collectively known as Procellarum creepterrane, or PKT. However, these substances are absent on the moon's far side. These ingredients were found in the models of the recent study, simulating volcanic activity on the near side due to the impact that formed the South Pole Aitken Basin. The South Pole Aitken collision is a significant event in lunar history, and understanding how the Procellarum creep terrain developed remains a crucial unanswered question in lunar science. As time goes on, more evidence will be needed to support this idea. So the next time you admire the moon's majesty, remember its hidden and uneven far side. Thank you for joining us on this cosmic adventure. Don't forget to like, subscribe, and hit the notification bell to stay updated on the latest mind-blowing discoveries in space exploration. Until next time, keep exploring the endless possibilities of space destiny.